Hi everyone and welcome to my lesson. Today we will talk about integration of rational function using partial fraction تكامل الدوال الكسرية باستخدام الكسور الجزئية. The degree of the numerator less than the degree of denominator. Case 2. If the factors of denominator containing repeated linear factors. If we have integral like this, integral of p of x over ax plus b all to the power n respect to x, and the degree of b of x less than n. If the denominator of rational expression contains repeated linear factors, then the decomposition looks like the following. b of x over ax plus b all to the power n equal c1 over ax plus b plus c2 over ax plus b all to the power 2 plus cn ax plus b all to the power n for constant c1, c2 and cn to be determined.
Evaluate the integral x minus 1 over x to the power 3 minus 3x dx. First, we need to find the partial fraction of this function x minus 1 over x to the power 3 minus 3x equal x minus 1 over, we can factorize this expression, we get x to the power 2 times x minus 3 equal, we have here a repeated linear factors, then we can write the partial fraction in this form: a over x plus b over x to the power 2 plus c over x minus 3. Then we can multiply by x to the power 2 times x minus 3 both sides, and we get x minus 1 equal ax times x minus 3 plus b x minus 3 plus c x to the power 2. Then we can use the zeros of our denominator to find the value of a and b and c. Then let x equal 0, 0 minus 1 equal negative 1 equal 0 times a equals 0 plus 0 minus 3 equal negative 3 b plus 0 times c equal 0. Then we get b equal 1/3. Let x equal 3 equal 2. 3 minus 3 equals 0 times a equals 0. 3 times minus 3 equals 0 times b equals 0 plus 3 to power 2 equal 9 c. Then we get c equal 2 over 9. Then we can use another value of x equal 1 to find the value of a. 1 minus 1 equal 0. A times x equal 1. 1 minus 3 equal negative 2 plus, we can substitute by b equal 1/3 and 1 minus 3 equal negative 2 plus c equal 2 over 9 times x equal 1 to the power 2. Then you can simplify this, we get a equal negative 2 over 9. Now we have x minus 1 over x to the power 3 minus 3x equal a over x plus b over x to the power 2 plus c over x minus 3, and we have a equal negative 2 over 9, b equal 1/3 and c equal 2 over 9. Then we can find the integral of this function. The integral of x minus 1 over x to the power 3 minus 3x dx equal a equal negative 2 over 9. Take it outside the integration. 1 over x dx. We have here b equal 1/3. Take it outside the integration of 1 over x to power 2. We can write in this way as a power notation, x to power negative 2 dx. Plus, we have here c equal 2 over 9. Take it outside the integral, 1 over x minus 3 dx. Then we have negative 2 over 9. Integral of 1 over x dx means natural logarithm of absolute value of x, plus here we can use power rule to find this integration. Then we can find x minus 1 over minus 1 plus 2 over natural logarithm of absolute value of x minus 3 plus constant. Simplify, negative 2 over 9 ln absolute value of x minus 1 over 3x plus 2 over 9 ln x minus 3 plus constant. We can use logarithm properties to make simplify. Then we can take 2 over 9 as a common factor from the first terms and the third terms. Then we have ln absolute value x minus 3 minus ln absolute value of x. This means ln absolute value of x minus 3 over x plus minus 1 over 3x.
Another example. By using partial fraction, evaluate the integral 5x minus 3 divided by x to power 3 plus 2x to power 2 plus x with respect to x. Rewrite the fraction 5x minus 3 over x to power 3 plus 2x to power 2 plus x. Here we need to use partial fraction to evaluate this integration. Then we need to factor the denominator. If we factor the denominator, we get x to power 3 plus 2x to power 2 plus x equal. We can take x as a common factor. Then we get x times x to power 2 plus 2x plus 1. Then we can factorize this expression again. We get x times x plus 1 to power 2. Then we can rewrite the fraction in this form. 5x minus 3 over x times x plus 1 to power 2. Here we have repeated linear factor. Then we can rewrite this fraction as a partial fraction as the following: a over x plus b over x plus 1 plus c over x plus 1 to power 2. By multiplying both sides of this equation by the common denominator x times x plus 1 to power 2, we get, then we can simplify and we get last 5x minus 3 equal a times x plus 1 to power 2 plus bx times x plus 1 plus cx. Let x equal 0, substitute by x equal 0. We can simplify, then we can find a equal negative 3. Let x equal negative 1, then we have 5 times negative 1 minus 3 equal a times negative 1 plus 1 to power 2 plus b times negative 1 times negative 1 plus 1 plus c times negative 1. Then you can simplify and we get negative 8 equal negative c. Then c equal 8. Now we are found the value of a and c. We need to find the value of b. Then we can substitute by x equal 1. We get 5 times 1 minus 3 plus a times 1 plus 1 to power 2 plus b times 1 times 1 plus 1 plus c times 1. Simplify, we get 2 equal 4a plus 2b plus c. And we can substitute by a and c. We get 2 equal 4 times negative 3 plus 2b plus 8. Simplify, and we get b equal 3. Then we can substitute now in our integration. Substitute by a equal negative 3, b equal 3, c equal 8. We get the integral of negative 3 over x respect to x plus integral of 3 over x plus 1 with respect to x plus integral of 8 over x plus 1 to power 2 with respect to x. Then we can take negative 3 outside the integral and the same with 3 and 8. But x plus 1 to power 2, we can write it in this form, x plus 1 all to negative 2. Then we can use our rule, integral of f prime of x over f of x dx equal natural logarithm of absolute value of x plus c. Then the first integral equal negative 3 natural logarithm of absolute value of x plus 3 natural logarithm of absolute value of x plus 1 plus 8 integral of x plus 1 all to power negative 2 with respect to x. The last integration, we need to use substitution method. Then we can let u equal x plus 1. Then du equal dx. Make substitution. Then we get integral of x plus 1 all to power negative 2 with respect to x equal integral of u to power negative 2 du. The integral of u to power negative 2 equal u to power negative 1 over negative 1 plus c1. Then we have negative u to power 1. Then substitute back by u equal x plus 1, we get x plus 1 to power negative 1. Then we have our integration equal negative 3 ln x plus 3 ln x plus 1, negative 8x plus 1 to power negative 1 plus c. If we need to make simplify again, we can use this rule, ln a minus ln b equal ln a over b, and a to power negative n equal 1 over a to power n. Then we get our integration in this form.